Hello guys, welcome to another video. This one is paper 1-3 of October-November 2019 of A-Level, paper 1. Now let's move on to question number 1. So first one, we have to expand this expression in ascending powers of y as far as y square. So let's do one by one. So first term is 6 choose 0. We have 1 n plus y. 0 here, this will be 0, and this will be 6 minus 0, that will be 6. Plus second term, 6 choose 1, that will be 1, that will be y. Here we have 1, that will be 1 here, and this will be 6 minus 1, that will be 5. And then finally, 6 choose 2, that will be 1, y, and this will be 2, and this will be 4. We can stop here because we only need to expand as far as the term in y square. Okay, so 6 choose 0 is 1 times 1 times 1 plus 6 choose 1 is 6 times 1 times y plus what is 6 choose 2? Let's check. That will be 15. So 15 times 1 times y square. This is equal to 1 plus 6y plus 15y square. That is your answer for part 1. Now let's move on to part 2. In the expansion of this expression, the coefficient of x squared is given by 48. Find the value of the positive constant p. So the reason why this was given as part 2 is we have to use part 1 to find this, right? So in part 1 you have the expansion of 1 plus y power 6. So it seems that we can compare these two. 1 and 1 is the same, and this is equal to y, and this is this. So conclusion for now, we have y is equal to px minus 2x squared. Now we have to put this thing into this expansion. So let's do that. It is equal to 1 plus 6y is px minus 2x squared plus 15 px minus 2x squared. Now, in this expansion, we are only interested in the coefficient of x squared. Okay? Now, let's expand and see what is the coefficient of x squared. That is 1. That is okay. So we have 6px minus 12x squared. Okay, that is the first thing we need to keep in mind. And then this one, let's do expand. Plus 15, that will be expand of square. We have p squared x squared. And then we have minus 4p x power 3 plus 4x power 4. But we don't need these because we only need the thing in power 2, right? So for now, we can ignore these two. We have minus 12x squared plus p, so plus 15p squared x squared. So now we have to combine these two. We have minus 12 plus 15p squared x squared. Okay, as we have seen, the coefficient is 48, so this is supposed to give you 48. So let's form an equation. We will have minus 12 plus 15p squared is equal to 48. So 15p squared is equal to 48 plus 12, that is equal to 60. So p squared will be 60 divided by 15, that is 4. So p squared, so p can be plus minus root of 4, which is plus minus 2. But now your answer is asking you for a positive value of p, so p can only be plus 2. And that is your answer for question part B of number 1. Okay. Now let's move on to question number 2. The function g is defined by g of x equal to this, for x is more than 4. Okay? By first completing the square, find an expression for g inverse of x and state the domain of g inverse of x. So one by one, first we have to complete the squares. So I like to write this down as g of x equal to x squared minus 6x, I like to leave some space, plus 7. So one thing I like to check is, we first check if the coefficient of x squared is 1. In this case it is 1. We can move to step 2. Step 2 is we have to add a number. So we have to add something here. The number you add will be this one. That will be 6 divided by 2 square plus 7. Now when you add something, you also have to minus the same number. So we have the same expression. Okay. So now let's simplify. You will have x squared minus 6x plus 3 square plus 7 minus 3 square. Now this will be x. Here we have minus. Now we minus. And here we have 3. You write 3. We have square. And what is plus 7 minus 9 should be minus 2. So that will be g of x. Now let's move on to part 2. Find an expression for g inverse of x. So to find g inverse of x, g inverse, we first have to let y equal to g of x, which is x minus 3 power 2 minus 2. So from this we can move on to the next steps. We have to make x become the subject of formula. So x minus 3 square is 2 plus y. Now x minus 3 will be square root of 2 plus y. Now x has to be 3 plus, so here we have plus minus 2 plus y. Now given the as you can see here, we have x has to be more than 4. So let's take the positive value of this one. 2 plus y. Okay, that is your g of x inverse. But of course you have to express in terms of x, because here we have y. It is not good. You have to rewrite this as g inverse. That will be 3 plus root of 2 plus x. Okay, that will be your g inverse of x. Now the last thing is to write down the domain of g inverse. So you have to know by now, domain of g inverse is equal to range of g. Okay, so from what you can see here, we have domain of this one. So g inverse is, so g of x is defined by, let's write down the complete square form. For x is more than 4. So what is the minimum value of this? So let's replace g of 4. That will give you 4 minus 1 is 1 square minus 2. That should be minus 1. So the range of g is more than minus 1, and consequently the domain is equal to the range of g. Domain is x is more than minus 1. That will be your domain of g inverse. And that will be your question number 2. Now let's move on to question number 3. The equation of a curve is given by y. The curve has no stationary point in the interval this and this. So find the least possible value of a and the greatest possible value of b. So let's see, what can that be, right? So first let's see where are the stationary points. So you would say at stationary points, we know that dy by dx is equal to 0. That's something we must know to solve those questions, right? So we have to find dy by dx. dy by dx is equal to, so power square plus 2x minus 8 equal to 0. So we have to factorize. That will be 3x times x, and 8 is what? 8 is 4 times 2. So we have 2 here, and we have 4 here. To get plus 2, we have to have plus 6 minus 4, right? So x can be 4 over 3 x can be minus 2. Okay, so now for you to understand this, we have to have, let's make a drawing for you to understand what's happening. Okay, so let's say what is the value of y when this is x. Y will be 4 over 3 cube plus 4 over 3 square minus 8, 4 over 3 plus 7. That should be 13 over 27. And what is the value of y for this one? So minus 8 plus 4 plus 16 plus 7. That will be 19. Okay, so let's make a drawing to see what's happening. So basically here you have your x-axis. And here you have your y-axis. Okay, so it seems that these two are two positive things. Let me see, because it's not possible usually, because one has to go below and one has to go up. Let me try again for this one. 4 over power 3 should be this, plus 16 over 9 minus 8 times 4 over 3 plus 7. Should be the same values. And this one, minus 2, will be minus 8 plus 4 plus 16 plus 7. 19. So let's check to see what happens. So basically at this point it is a positive point. It will be here. And the value shows to be, what is this? 4 divided by 3. So 1 point something. And this one is minus 2. Okay, so these two are stationary points. Basically, this is 19. That will be up here. And this is a bit below. That should be around here. Okay, I see. That is good then. So in that way, basically what happens is, this will be your maximum point, and this is your minimum point, right? So your curve will look something like this. This, and this will go up. Now, as you can see, so this will keep going down as well. Right. Now the question is asking you, what is the value for the intervals where they don't have any stationary points? But you can see that between these two, there's no stationary points. So in that case, you know that between the range of minus 2 and 4 over 3, there's no stationary points. So that's how you find your values for A and the value for B. So in this case, A has to be minus 2 and B will be 4 over 3. According to the diagram, between those two regions, there's no stationary points. And that's how you find the interval as required. So this is just to understand what's happening, but usually we have to use this technique to find those 2 points, and from those two you can see where the range is, where the domain is, where there's no stationary points. Now let's move on to question number 4. The diagram shows a semicircle ACB with a center O and radius R. This is R, this is R as well, right? This is R. Arc OC is part of a circle with a center A. Okay, part 1. Express angle CAO in radians in terms of pi. So this one you have to observe because it is not very obvious. Sometimes it can be, but not really. If you do this, let's join C to O. Okay, so if you observe here, we have a triangle CAO. With this is your radius, this is radius as well, and this is also radius, which means all the 3 sides are the same, so the angles have also to be the same, which is 60 degrees, which is pi by 3 radians. So you can write this down. Angle CAO is pi by 3 radians, because all the sides are the same for triangle CAO. Now for part 3, find the area of the shaded region in terms of R, pi, and root 3. So how would you find the area of that region. So now if you observe, we have a triangle ACB over a semicircle. This angle will be 90. So to find the area, we must first find the area of triangle and then minus the area of sector. Okay, so now how would you find area of triangle? As you guys know by now, half times base times height. So we have to have this side and this side. So we see this side we don't know, so we have to first find this side. So we have to find this side by using SOHCAHTOA. So this is your A side, and we're trying to find your opposite side. So we have to use tan. Tan of pi by 3 is equal to BC over R. So BC will be R tan pi by 3. Now what is tan pi by 3? So tan of 60. So you should know this. It is equal to root 3. Okay. So that will be BC will be R. So root 3 over. That will be BC. So let's do that. First thing is we have to find the area of triangle ACB. Half times base times height. That will be root 3 over 2 R square. That is area of triangle. And so now we have to minus the area of sector. So this one is also found by using a formula. Area of sector CAO, that will be half R square theta, which is the angle. Half R square is R square, theta is pi by 3. Okay, so since we have the area of the triangle, we have the area of sector, so we have to minus. So this minus this will be area of region. Area of shaded region will be first one minus half. So let's factorize. So this can be your answer, but we have to simplify it, right? So we can take out half and R square outside. You will have root 3 minus pi by 3. That will be centimeter. I think it is units. We don't know what is the value. So units square. That will be the shaded area. And that is for question number 4. Now let's move on to question number 5. The dimensions of a cuboid are given to you by x, 2x, and 4x. Now part 1, show that the surface area S and the volume are connected by the relation. So let's first one by one. So let's first find the surface area S. So what is that equal to? As you can see, we have 1, 2, 3, 4, 5, 6 surfaces for this object. So let's find the area first. So first is this side. So we have x times 2x, that would be 2x squared. But we have to times 2 because it is front and back. And this one is 4 times x, that will be plus 4x squared, but times 2 for this and back side. And the top will be plus, this is 2 as well, this is 4, that will be 8x squared. But we need to times 2 because it is top and base, right? Now that will be 4x squared plus 8x squared plus 16x squared. That will give you 4 plus 8 plus 16, 28, right? So 28x squared will be your surface area. Now what is the volume of the shape? As you guys know by now, volume will be length times width times height. That will be 2x times x times 4x. That will be 8x cubed. So V is equal to 8x cubed. So let's see how can we let's see how can we relate them to each other by this equation. So something we can do here is so here we have x squared. Let's make x become the subject of formula. right? So here we have x. So x squared is equal to s over 28. From this you have x is equal to root of s over 28. So this is basically s over 28 power half. Now let's replace this x in this x. So you will have v is equal to 8 x cubed is s over 28 power half. Sorry, power half, but it is power 3, so that will be 3. Okay, because we have x power 3. So basically x, if x is equal to s over 28 and 1/2, so x power 3 has to equal to s over 28. We have to increase this to 3. That's why we have this right now. So here we have to make x become the subject of formula, so let's do that. First step is we have to send this over here. You will have v over 8 equal to s over 28 3 over 2. Now what is the next step? We have to, this is s, not 8s. Then we have to send the power over here. You will have s over 28 is equal to v over 8 power 2 over 3, which is v 2 over 3, and this is divided by, so that will be 2 in that case. Now let's see what we have. So, oh no, this is not 2, because let's try 8 power 2 over 3, that should be 4, not 2. That should be 4, the base become 4. So right now we have s over 28 is equal to v power 2 over 3 over 4. Now simplify, we have to send this one over here. You will have s is equal to v 2 power 3 over 4 times 28. So s is equal to 7 v 2 power 3. Okay, so that will be the equation connecting s to v, which is this, and shown as required. Now let's move on to part 2. When the volume of the cuboid is 1000, so when v is equal to 1, 2, 3, the surface area is increasing by, so increasing will be ds by dt is given by this 2, right? Now what is the formula for the volume? As you guys know, volume is given by length times width times height, will be 8x cubed is equal to 1000. So what is the value of x cubed? That will be 1, 2, 3 divided by 8. So x will be 10 over 2, which is 5. So basically when x equal to 5, ds by dt is equal to 2. Now we need to find the find the rate of increase of volume at this point. So we have to find rate of increase, so dv by dt. So to find this, we need to form an equation. So dv by dt is equal to, on top we have dv, we have to multiply by, below we have dt, and what connects these two? As you can see, ds connects these two. So here we have ds by dt is equal to 2. So we have to find dv by ds. So now we already have an equation connecting these two. So we have s is equal to 7v 2 over 3. So we have to find dv by ds, but we can first find ds by dv. That will be, we have to multiply by the power first. That will be 7 v times 7, of course, minus 1, that will be minus 1 over 3. That will be 14 over 3 v 1 over 3. Now for dv by ds, that is equal to 3 1 over 3 over 14. But now we have to find the value of this when v is equal to 1000. So I think this is not necessary over here because we have been given this value already, so we can just use that to find this value. So we have to find dv by ds when v is equal to 1000. That will be 3 times 1000 power 1 over 3 divided by 14. So now by solving this value, we have 3 times 1000 power 1 over 3. That should be, which doesn't seem to be quite normal, because let's try again. 1000 power 1 over 3 is what? Is this? Doesn't seem to be quite right. Oh, I think I know why. We should do this one. Power, bracket inside 1 over 3. You will have 10. 10 times 3 will be 30 divided by 14. 30 divided by 14 should be 1 over 7. So this is your value of ds by dv. So to find the value of dv by dt, we have to replace that back in your equation. You will have 217 times 2. So times 2, that will give you 4.2857, which is 4.29. That will be in terms of centimeters cube per second for the rate of change of the volume. And that will be your question number 5. Now let's move on to question number 6. A line has equation y and the curve have equation this one, where k is a constant. Now part 1, find the set of values of k for which the line and the curve meet at 2 distinct points. So whenever you see this, you have to know, you have to use b squared minus 4ac is more than 0. But first we have to solve them simultaneously. Here we have y and here we have y. Let's replace on both sides. On one side you will have 3kx minus 2k is equal to x squared minus kx plus 2. Now let's send everything to one side. You will have x squared minus kx minus 3kx plus 2 plus 2k is equal to 0. Now you have x squared. Now we have plus, then we have minus k minus 3k x plus 2 plus 2k equal to 0. Now we can simplify this. That will be x squared plus minus 4k x plus 2 plus 2k equal to 0. As you can see here, we have a quadratic equation. So we have to find a is equal to 1, b is equal to minus 4k, and c is equal to 2 plus 2k. Now we have to go back to our equation. This one is b squared minus 4ac has to be more than 0. So b squared will be 16k squared minus 4 times a, which is 4, times c has to be more than 0. 16k squared minus 8 minus 8k is more than 0. Now if you divide by 8 everywhere, you will have 2k squared minus 1 minus k. So let's rearrange. You will have 2k squared minus k minus 1 is more than 0. Now we first have to find the critical values, which means we have to equate that equation to 0. Then we have to factorize and find the critical values. That will be 2k times k, 1 is 1. To get minus 1, we have to have minus 2 plus 1. So you will have k is equal to minus half, k is equal to 1. Now to find the set of values of k, we have to look at your graph. Now since it is a positive value, the graph will look something like this. It's a minimum curve. This will be your minus half and this will be your 1. Right. Now we need this to be, this is your line 0, has to be more than 0, which means has to be above this line and above this line. So your value of k has to be less than this, and k has to be more than 1. So these two will be the values of k for which this is satisfied. So part 2, for each of two particular values of k, the line is a tangent to the curve. So we have a curve y is equal to x squared minus kx plus 2. That's the curve. So it says for each of the two values of k, so we have the range, k is less than this, and k has to be more than 1. That's the range of k, right? So for two values of k, that is for part 1. Part 1 is b squared minus 4ac is more than 0, which means it cuts at 2 points. It cannot be a tangent, so we cannot take those values as this one. Here we're looking for tangents. As you can see, for tangents it is b squared minus 4ac equal to 0. So the two values of k will be k is equal to this and k is equal to 1. So for those two values of k, it will be tangents. So this one is for part 1, this one will be for part 2, okay? Because here we're looking for tangents. Show that these two tangents meet on the x-axis. So basically we first need to find the equation of tangent so we can know if they meet on the x-axis. So the line that we know is this is the curve. The curve is okay, but we need to find the line. The line is 3kx minus 2k. Okay, now let's take a look at one by one. If the value of k is, for k is equal to minus half, what is your equation of tangent? It will be y is equal to 3 times minus half x minus 2 minus half. That will be minus 3 over 2x plus 1. That is your equation of tangent when k is equal to this. Now next one, when k is equal to 1, your value of y will be 3 1x minus 2k. So y is equal to 3x minus k is 1, so minus 2. That will be your first equation. That will be your second equation. So now we have to show that these two meet at the x-axis. So basically at x-axis, you know that the value of y has to be 0. So we have to show that when y equal to 0, they have the same x value. So let's replace this one here. You will have y is equal to 0. You will have minus 3 over 2 x plus 1. So you will have 3 over 2x is equal to 1. So x is equal to 2 over 3. That is for part 1. Now for this one, let me use a different color. So y is 0. So you will have 3x minus 2. So 3x is equal to 2. X is equal to 2 over 3. As you can see, they meet at the same point on the x-axis. So you can show this, shown as required. They meet on the x-axis at the same point. Okay, that will be your question number 6. Now let's move on to question number 7. Show that the equation, this, can be expressed in this way, where x is equal to cos square theta. Okay, so pretty easy. The one thing we do here is 3 cos power 4 is what? Is cos power 2 square plus 4. What is sine square? It is 1 minus cos square minus 3 is equal to 0. So simplify, that will be cos square theta square plus 4 minus 4 cos square theta minus 3 is equal to 0. That will be 3 cos square theta square minus 4 cos square theta. 4 minus 3 is plus 1 equal to 0. So now we have to replace the value of cos square theta by x. So you will have 3x squared minus 4x plus 1 equal to 0. As you can see, this is shown as required. That is for part 1. So now for part 2, hence means using part 1 to solve this equation for the domain between these two values. So let's do one by one. So first we have this one as seen from part 1. So first we can factorize them, right? You will see two brackets. Then you will have 3x times x. 1 is 1 times 1. To get minus 4, we have to have minus 3 and minus 1. So x has to be 1 over 3. X has to be 1. Now, as you guys know already from part 1, we say that x is actually equal to cos of theta, right? Now, cos square. So replace that back to this, you will have cos square of theta will be 1 over 3, and cos square of theta will be 1. So let's solve one by one. So here we have cos square of theta is, cos theta is plus minus root of 1 over 3. Okay, and here we have cos of theta is plus minus 1. So let's solve this one first. So let's take the negative value first, and then we take the positive value afterwards. So you guys must know when cos is negative, it will be in your second quadrant, which is 180 minus theta, and your third quadrant, which is 180 plus theta. Okay, so here you can see the range is only in the first and second quadrant, so we're only going to be taking this one value, which is this one. So basically theta is equal to cos inverse of the positive value of this. So let's see what we have. In terms of degrees, cos inverse of root 1 over 3. That should be 54.7. So that is not the value you're looking for. You're looking for this one, which is 180 minus theta. So finally, theta, the real theta, let's put a mark here. So we know it's not the real one we're looking for. The real theta will be 180 minus this. That should be 125.3. That's the first value of theta. Now when cos is positive, it will have to be in your first quadrant and in your fourth quadrant. That will be 360 minus theta. Again, as you can see, we have a domain in your first and second quadrant, so we only need to find this one value. So theta is equal to cos inverse of the value 1 over 3, and that should give you 54.7, and the value of theta will be only this one, which is theta itself, for 54.7. So here we have two values for this one. Now for this one, we have cos theta is equal to minus 1. Again, using the same technique, that has to be in your second quadrant, which is 180 minus theta, and also in your third quadrant, which we don't need because of the domain. Now first step is to find the, so let's say this one, the fake one, that will be cos inverse of the positive value of 1. That will be 0. Okay, so it means that your value of theta has to be 180 minus 0. That should be 180. Okay, and now for the positive value 1, it has to be in your first quadrant. Okay, so that will be, so let's find out. So theta will be cos inverse of 1 again. That should be 0. So your answer will be angle 0 which is this one, but also 0 is right here, but also 360. Why? Because if you do a complete revolution, you will come down to the same value. But now, since of course because of the domain, you will not take this one. So your final answers will be theta has to be between, so you have 0, you have 54.7, you have 125.3, and you have 180. These will be the values of theta that satisfy your equation. That will be your question number 7. Now let's move on to question number 8. A function f is defined for x is more than half, that's the domain, such that f prime of x is equal to this. Now part 1, f prime is what? First you have to know f prime is simply d by dx, okay, the gradient basically. Now find the set of values of x for which f is decreasing. So when f is decreasing, we have the condition of f prime of x has to be less than 0. So let's solve this equation. You will have 3 times 2 x minus 1 half minus 6 has to be less than 0. So you have 3, 2x minus 1 power half has to be less than 6. 2x minus 1 power half has to be less than 2. And we have 2x minus 1 has to be less than 4. 2x has to be less than 5. X has to be less than 2.5. That will be a set of values of x for which it is decreasing. That is for part 1. Now let's move on to part 2. So we have to write this down again because we have a limit, as you can see. X has to be more than this. So basically we have two conditions. X has to be more than 0.5 and x has to be less than 2.5. So the range will be x has to be between 2.5 and 0.5. So that will be your answer for part 1. Okay, so we have to write this in this way because we have two. The first one is here and this one is found afterwards. Now let's move on to part 2. It is given that when x is equal to 1, the value f is equal to minus 3. Okay, so we have to find f of x. F of x is just, we have to find the value of y. So as you guys know, f of x will have to be found by using integration of f prime of x with respect to dx. That will be integration of 3 2x minus 1 power half minus 6 dx. That is f of x. That should be equal to, so first we have to increase the power by 1. That will be 3 over 2 divided by the same power and divide by 2 minus 6x plus c for f of x. Now let's see what happens. So this cancel out, and this cancel out. So you will have 2x minus 1 power 3 over 2 minus 6x plus c. That is for f of x. Now we have to find the value of c. So we have been given that in part 1. When x is equal to 1, so f of 1 is equal to minus 3. So f of 1 is what? That will be 2 times 1 minus 1, 3 over 2 minus 6 times 1 plus c is equal to minus 3. That will be 2 minus 1 is 1, so that will be 1 minus 6 plus c equal to minus 3. 1 minus 6 will be minus 5 plus c equal to minus 3. C will be 2. So when you find the value of c, you can replace back in your equation to find f of x. Now f of x is actually equal to 2x minus 1, 3 power 2 minus 6x plus the value of c. And that will be your equation of f of x. That is your question number 8. Now let's move on to question number 9. So the first, second, and third terms of a geometric progression are given by this, respectively. Part 1, show that k satisfies this equation. So now for you to understand, let's write this down again. So the first term is given by 3k, second term is given by 5k minus 6, and third term is given by 6k minus 4. Now, the most important thing is that we know already it is a geometric progression. Now, if you look at your sheet, usually at your formula sheet, it tells you something about geometric progression. So for geometric progression, you have a R, which is your common ratio, right? So R, we have a first term. This is your first term. Here we know it is equal to 3k, and R is your common ratio when it comes down to a geometric sequence. So how do you find a common ratio? We know that we have to use term by term. So let's use these two. We know that we have to multiply this by R to find this, and multiply this by R to get this. So let's find this value of R. So for the first one, it will be 5k over 6 divided by 3k. And for this one, it will be 6k minus 4 over 5k minus 6. Now, these two values of R are the same, so we can equate them with each other. So you will have on one side this, and the other side you will have this one. So we have to cross multiply. You will have 5k minus 6 square equal to 3k times 6k minus 4. Now we have to expand. You will have 25k square minus, that will be 60k plus 36 equal to 18k square minus 12k. Now let's send everything to one side. 25 minus 18, that should be 7k square. Then we have minus 60 plus 12, that will be minus 48k. And then we have plus 36 has to be equal to 0. This is shown as required. Okay. Now for part 2, find, showing all the working, the exact values of the common ratio, which is R, corresponding to each possible values of k. So let's do that. So we have the equation 7k square minus 48k plus 36 equal to 0. So we have to factorize. So 7k is 7k times k, 7k squared, right? And this one has to be 6 times 6. So to get 40 minus 48, we have to have minus 42 and minus 6. So k can be 6 over 7, or k can be 6. So for each values of k, let's find the value of R. As you have seen, R is equal to this equation. So let's write this down again. R is equal to 5 times k minus 6 over 3k. So R is equal to, for this first value of k, so 5 times 6 over 7 minus 6 over 3 times 6 over 7. 6 over 7 minus 6 divided by 3 times 6 over 7. That will be minus 2 over 3. And for this one, for this value of k, R will be 5 times 6 minus 6 over 3 times 6. 5 times 6 minus 6 divided by 18. That should be 4 over 3. So we have two values of R for these two values of k. And that is part 2 of question number 9. Now let's move on to part 3. So one of these ratios give a progression that is convergent. Find the sum to infinity. So we have to know the sum of infinity is only possible if the magnitude of r, this one, has to be less than 1. So that is only possible when that is true. Now this is the equation for this is a over 1 minus r, right? A is your first term. A has been given to you as, so let's first look at the value of r that is possible. So we have to choose this one for less than 1, right? So we will take r as minus 2 over 3, for which the value of k was 6 over 7. Now, when k is this, the value of a, which is your first term, it is 3k. 3 times k is this. That will be 18 over 7. Now replace back in your equation for sum to infinity. A will be 18 over 7 divided by 1 minus 2 over 3 for your value of r. 18 divided by 7 divided by 1 minus 2 over 3. That should be 1.542 SF, or you can write in terms of fraction, should be 119 over 35. That will be your sum to infinity, and that is your question number 9. Now let's move on to question number 10. Relative to a point O, the position vectors of A, B, X has been given to you. Now part 1, find AX, so let's do that. AX is given to you by OX minus OA. That will be, OX is minus 2, minus 2, 5, minus 8, minus 4, 2. That should be minus 2 plus 8, that should be 6. Minus 2 plus 4, that should be 2, and that should be 3. That will be AX. Now we have to show that AXB is a straight line. So you can show this by showing that, let's, for example, we have a line here. This is A and this is B. We want to show that X is somewhere around here. So to show that it is a straight line, we can show that AX is a multiple of AB. Okay, so we have to find AB. So AB is what? AB will be OB minus OA. So OB has been given to us by 10 to 11 minus OA minus 8 minus 4, 2. That will be 10 minus 8, that will be 18. 2 minus 4, that will be 6, and that will be 9. Now, we have those two values, we have to show that they are multiple of each other. So, how can we show this? So, if you look at this, we can take out the value of 3. You will have, 2. You will have 3, 1, and okay, this is not possible because, so I guess that's the minimum we can change that. That is already simplified, because here we have 2, here we have 3, here we have 6, so we cannot simplify anymore. Now let's try this one. If you want to do this, let's take out the value of 3, for example. You will have 6, 2, and 3. Okay, so now if you observe, this thing right here is the same as this, which is 3 times bigger than this. It means that they are a multiple. So hence you can write this down by showing AX, which is this, 6, 2, 3, is 1/3 of AB, which is 18, 6, 9. You can write here AX is 1/3 of AB. So we have to show this multiple value by showing that it is, you have proven that AXB is a straight line. Okay, that is for part 1. Now for part 2, the position vector C has been given to you by this. Now part 1, we have to show that CX is perpendicular to AX. So first let's find CX. That will be OX minus OC. OX has been given to you by -2, -2, 5, minus OC, 1, -8, 3. That should give you -2 minus 1, that should be -3. That will be 6, and that will be 2. Okay. Now to show that it is perpendicular, we have to show that the dot product of these two directions has to give you 0. So let's find that. -3, 6, and 2 multiplied by AX, which is given by 6, 2, 3. That is -18 plus 12 plus 6 has to be 0. So you have shown that it becomes 0. Thus, CX is perpendicular to AX. Now for part 3, find the area of triangle ABC. So let's find that area. So how would you find that? So let's see, what do we have in common? So we have, let's say we have a point A over here. So point O here. Let's say A is somewhere. So we have to find the sides first. We can do that, or we can just use our formula as well, which is the array method. But okay, whatever. Let's see what can we do in that case, because I think we have to use this information for that one. So first part is, as you can see, we have proven that AXB is a straight line. So let's draw a straight line. So here we have a straight line, for example. A, X is here, B. It is a straight line. That's the first thing we know from part 1. Now, we have shown that CX is a point which is perpendicular to AX. So, has to be perpendicular to it. So AX will be this direction. So CX has to be perpendicular, so it has to be in this direction. That will be your point C. So now you have to find the area. So this is perpendicular height. So we have to find your area of triangle A, B, C. So how do you find area of triangle? It is half times base and times height. The base is equal to AB, as you can see, and the height is equal to CX or XC, same thing. So we have to find the magnitude of these two vectors. So what is the magnitude of, so we know AB is given by this vector, which is 18, 6, and 9. So AB magnitude will be, that will be 18 square plus 6 square plus 9 square, 441. And we know that CX has been given to you by this, which is -362. So CX has to be 9 plus 36 plus 4. That will be 49. So now replace back in your equation to find the area. So area is equal to half times AB, which is root of 441, times length of CX will be 49. So half of times root of 441 times root of 49, that should be 73.5 units square for the area of triangle ABC. So it's always best to make a drawing to understand what's happening and then find the length to find the area. That will be your question number 10. Now let's move on to question number 11. So I think in the main question this is shaded in the question. So let's do that first and see what question do we have. Okay, so the diagram shows part of the curve y. This is the curve, and the line x equal to 1 and 3. Okay, Now the point A is on the curve, has coordinates 2, 3, as you can see here. The normal to the curve at A crosses the line x equal to 1 at B, at this point B. Now question number 1, show that the normal at AB has equation y equal to this one. So we have to find the equation of the line AB. So how would you find that? So let's see, what can we do? So to find the equation of a line, we must first find the gradient of a line, right? So we can use this one to find the gradient. So we can first use dy by dx. So dy by dx will be minus 2, x minus 1, minus 3, 0. So we have to find dy by dx at the value of x equal to 2. That will be minus 2, 1 power minus 3, that will be minus 2. So this is the gradient of the tangent, but we need the gradient of the normal, that will be half. Now we have a passing point, which is the point A, which is the passing point, 2, 3. That will be x, y. Now to find the equation, we have to do y minus 3 over x minus 2 equal to half. Now we have to cross multiply. You will have 2y minus 6 is equal to x minus 2. That will be 2y is equal to x plus 4. Now you can simplify. You will have y is equal to half x plus 2. This is shown as required for part 1. Okay, so now moving on to part B, we have to find the volume of revolution obtained when the region is rotated 360 about the x-axis. So you have to know that whenever you see about the x-axis, we have to use the formula V, which is the volume, is equal to integration of pi times y square by dx. This is for x-axis. Now as a side note, if it was by the y-axis, you will use the formula pi by x squared dy. This is about the y-axis. So for now we have to use this one. But the first step, as you can see, we have to break this one into two parts. As you can see, we have to first find the volume for part A and the volume for part B. For part A, it is below this straight line. For part B, it is below this curve. So one by one. So let's find part A first. A will be integration below the straight line. So the limits has been given to you as well. It is between 1 and 2 for A. So 1 and 2. So that will be 2, 1. And we know that y is given by half plus 2. So what is y squared? That will be half x plus 2 squared. Replace, you will have half x plus 2 squared by dx. Now simplify. Let's see what we have. We can first take out the value of pi. Now integration, that will give you half x plus 2 increased by 1, that will be 3, divide by 3, and then we have to divide by 1 over 2 between the limits of 2 and 1. So I think this is part A. So let's simplify this much further. So let's see what we can do. First, we place the value of 2 inside. You will have, so this will become 2 will go up, that will be 3, and you will have, first part will be half times 2 will be 1 plus 2 is 3, 3 power 3. Now minus 2 over 3, that will be 1 now, 1 plus, so 2 plus 1 is 2.5, that will be, we can write 2.5 or 5 over 2, power 3. Now let's simplify and see what are the values that we can have for these two fractions. So for the first one, it is 2 times 3 power 3 divided by 3. That should be 18 minus 5 over 2 power 3 times 2 over 3. That should be 10, 5 over 12. So 18 minus 10 over 5 over 12, that should give you 7, 712 pi. That's the first part. This A is given to you by this, units cube. So now we have to find the volume of B. B, we use the same formula, but the y will change this time between the limits of 3 to pi y squared, because y has been given to you for the curve for B is this one, which is x minus 1 power minus 2 plus 2. So y squared will be x minus 1 square. We have to simplify. You will have x minus 1 plus 4, x minus 1 plus 4. Replace y squared by this. We have this over here, right? That will be by dx. Now the first step is we can take out pi as we have seen previously. That will be 3, 2, and then we have this plus 4 times x minus 1 minus 2 plus 4 by dx. Now let's simplify one by one. First one, we have to increase the power by 1. You will have minus 3. Then divide by the power plus 4. That will be minus 1. Divide by minus 1. That will be 4x between the limits of 3, 2. Now next one is, let's simplify. You will have minus 1 over 3 times x minus 1 power 3 minus 4 over x minus 1 and then plus 4x between the limits of 3 and 2. Now let's replace one by one inside. You will have, for first one is 3, that will be minus 1. So it will be 3 minus 1 is 2. 2 power 3 will be 8. 8 times 3 will be 24. Minus 4 over, that will be 2, plus 12. Then minus, that will be minus 1 over 2 minus 1 is 1, that will be 3. Minus, that will become 1, minus 4, and plus 8. So let's simplify. Minus 1 over 24, minus 2 plus 12, that will be 13, 2, 23 over 24. So let's check again, because I think there may be a problem here. So here we have minus 2 plus 12. That will be 10 minus 1 over 24. Okay, that will be just 9. 9, 23, 24. Okay. Now we have minus. So here we have minus 1 over 3 minus 4 plus 8. That will be, so let's try again. Oh, so I see I put plus 4, my mistake. Minus 4 minus 8, that should be, okay, mistake again. So minus 1 over 3 minus 4 plus 8, that should be 3, 2 over 3. Okay, now this minus this should give you what? 9 over 23 over 24 minus answer, that should be 6, 7 over 24. So finally, your value of B will be 6, 7 over 24 pi units cube. But now the answer is A plus B, which is 7, 7 over 12 pi plus 6, 7 over 24 pi. So plus 7 over 12 times pi, that will be 43.6 units cube, correct to 3SF. And that will be your question number 11. So that was the last question of this paper. As always, I hope that was helpful. And if you guys have any questions, please leave a comment down below. I will get back to you guys. And thank you for watching. I will see you soon.